Hi, and welcome to day one of the complex numbers unit. Um, Today we're going to be talking about overcoming a third obstacle to factoring. What if there are no real number solutions? So on your graphing calculators, I want you to do these problems. It says find all solutions to each of these systems of equations below by using any method. The quickest and easiest way to do this is by using your graphing calculator and getting them all into y equals form and then plotting everything and seeing what happens. So just briefly, I'm going to just draw what the pictures look like, and when you have a minute, if you have your graphic calculator at home or if you have to wait to school to do it, then that would be fine. So when I graph these two lines, it will look something like that. And they will actually be parallel because their slopes will be the same. And then for this one here, you're going to have a parabola and a line, and it's going to look like that. And again, they're not going to intersect. And then for this one actually is just easiest to do without a calculator. X squared plus y squared is a circle, and it equals 1. So you're just going to have a circle centered at the origin with a radius of 1. And then for this one, it's going to be x squared plus y squared. It's another circle centered at the origin with a radius of 2. So it's going to look like this. So they're two concentric circles, so therefore they don't intersect. So all three systems have no real number solutions. So there's no real number solutions. Sometimes that means there's no solution at all, and sometimes that means that you might have some other kind of solution, and we will be talking about that this unit. So, moving on to the next problem here. Are there any real number solutions to the system y equals 4 and x squared plus y squared equals 2? Support your findings both analytically and graphically. So that means that we need to actually draw a graph. And y equals 4 will be a horizontal line up here. X is supposed to be a 4. This is x, getting ahead of myself here. And then x squared plus y squared equals a circle with a radius of radical 2. Well, radical 2 is less than 2 but more than 1. It's about 1.7, so I was trying this on graph paper to be a little bit better. But as you can see, there are no solutions, and if I were to find this algebraically, I would just substitute 4 in for y. So I'd have x squared plus 4 squared equals 2. So x squared plus 16 equals 2. So x squared equals, I need to subtract 16 from both sides, negative 14. And we know that we cannot take the square root of a negative number and get an answer, so therefore it works that there is no real solution. All right, next page. Does the line y equals x intersect the parabola y equals negative x squares? If so, how many times and where? So I need to draw my axes here. There's y. And then here's x. So the line y equals x is just this diagonal here. I'm going to do my best to connect the points. And this is in line y equals x. And then for my parabola, I'm going to use my calculator and -2, -1, 0, 1, and 2. If I put -2 in and I square it, I'll get -4. If I put -1 in and square it, I'll get -1, 0, 1 is -1, and if I put 2 in, I'll get -4. Because remember, this is -1 times x squared. So after I square the number, I then need to multiply it by a negative. If you don't believe me, put it in your calculator. So -2, 4, -1, 1, 0, 0, 1, -1, and then 2, -4. I think I said -1, 1 instead of -1, -1. And this is y equals -x squared. Oh, well, I certainly didn't mean to do that. Here and here is where they intersect. So they intersect at the point 0, 0, and at the point -1, -1. So it asks how many times, so it would be 2 times, and where. I already drew that for you on the axes at 0, 0, and -1, -1. Does the line y equals -x intersect the circle x squared plus y squared equals 1? If so, how many times and where? And then draw the graphs on the same set of axes. Well, y equals -x. I gotta draw my axes in first. Okay, hang on. Alright. So draw my axes in. That's my y-axis. This is my x-axis. And the lines y equals -x is this diagonal here. And then the circle is x squared plus y squared equals 1. So that is a circle, radius of 1, which is right here. And it would be 2 times. But where is a lot harder to see. We're actually going to have to solve it algebraically to find the where. So where I see a y, I'm going to put -x. So x squared plus -x squared equals 1. So I will have x squared plus x squared equals 1. So I will have 2x squared equal 1. So I divide by 2. I will have x squared equals 1 half. And then if I take the square root, I will have x equals plus or minus 1 over radical 2. And then earlier in here, we can't do radical 2 as well. We can make that, so we'll plus or minus radical 2 over 2 for our x values. And then to find our y values, y is equal to -x. So I have y equals a negative radical 2 over 2. So y equals negative radical 2 over 2. So I have the point radical 2 over 2, negative radical 2 over 2. And then I'd have to do the same thing with the negative radical 2 over 2. So that would be y equals positive radical 2 over 2. So that point would be negative radical 2 over 2 radical over, or comma, radical 2 over 2. So that's what happens there. It's not very easy to see those. I mean, it's easy to see the points, but it's not easy to find the values. If you were to use the trace feature on your calculator, you would get a decimal value, and it would be 0.7071 or 0.71, right around in there. So that's what you would be looking for on the calculator. All right, one last problem. Does the line y equals 5 intersect the parabola y equals 4 minus x squared? Why or why not? Draw the graphs on the same set of axes. Well, let's draw the axes in first, and we can graph the line real easily. This is y, this is x, y equals 5, so it's 1, 2, 3, 4, 5. So this is y equals 5. And then for y equals 4 minus x squared, I could go to my graphing calculator, or I can use what I know about them. Is I'm just going to take my negative x squared and go up 4, and then plot my points, which you can find on the graphing calculator. And it'll look something like this. So this is y equals 4 minus x squared, and you can see that they do not intersect. So the answer is no, and they don't intersect because if I were to solve this algebraically, put a 5 in place of y, I'd say 5 equals 4 minus x squared, so subtract the 4. Oh, make that happen. I'll get 1 equals negative x squared. And do I have a negative 1 here? I will get negative 1 equals x squared. There is no way I can square a number and get a negative value. Therefore, they cannot intersect algebraically, and graphically I've shown you why. Alright, that's it. This was a short one. What I want you to do for me is right here, look up the quadratic formula. I'll give you this much, x equals. I want you to look up the quadratic formula and write it in your notes. We're going to need to talk about that in class. Alright, that's it for today's notes.